Today we're going to run through periodic trends, including atomic size, ionic size, electronegativity, ionization energy, and electron affinity. Let's get started. Atomic size is simply how large the atom is going to be. Atomic size increases as you move left across the periodic table and down towards francium. I've written some important highlights on this slide here. In case you were wondering why atoms become smaller across a period, it is because of increased effective nuclear charge. Essentially, there are more protons as you move from left to right across a period, and no increase in the orbits of electrons. This causes a pull on the electron towards the nucleus that is increased, causing the electron cloud to decrease in size. So what I mean by that is, let's take for example hydrogen. I say this is the nucleus right here. There's one proton. And let's say we have helium here. We have two protons. Okay. And we also know that helium has two electrons in an orbit. And since it's located on period 1, there's only one ring around helium that contains electrons. So there's two electrons here. And for hydrogen, it's also one concentric ring around it with one electron. So since helium has a greater number of protons, there's more pull on these electrons towards the nucleus, which causes the overall size of the nucleus, or the atom itself, to become smaller. So therefore, helium will be a smaller atom than hydrogen. And other things to remember about atomic size is that it's different from ionic size. We will cover this in the next slide. As I mentioned earlier, ionic size is not the same as atomic size, so this is a very important point. So now if I were to ask you which ion is smaller, oxygen or magnesium, so O2 minus or Mg2 plus, using atomic trends, you would probably answer that oxygen is smaller, but that is not the case. So let's look at the periodic table. We see here neutral elements of magnesium and oxygen. So magnesium over here and oxygen right here. So in our example, we were trying to compare oxygen 2 minus, so it's an anion, versus magnesium 2 plus, which is a cation. So magnesium in this case has lost 2 electrons, which makes it 2 plus. So the electron configuration is actually going to be neon. So let me use a different color right there. So neon. Oxygen, on the other hand, has gained 2 electrons, which gives it the charge 2 minus. So this actually, the oxygen moved up 2. So it also has the same number of electrons as Mg2 plus. They're both the same electron configuration as neon. So wouldn't they be the same size? Well, no. It's because we need to look at protons once more. Magnesium has more protons than oxygen. Therefore, the effective nuclear charge, the same concept as atomic size, will make magnesium a smaller atom than oxygen. And since oxygen gained 2 electrons, it makes it larger in size because the electron cloud volume also increased. Now let's look at electronegativity. This trend increases as you move right and towards the top of the periodic table, so up and to the right, especially towards fluorine. Now, in this case, we exclude the noble gases because they are already stable. They already have 8 electrons for their valence, and therefore they have an electronegativity of 0. I will explain this further in the next slide. Electronegativity is defined as the ability of an atom to attract shared electrons to itself. In the case of noble gases, since they already have a completed octet, they have no reason to attract shared electrons to themselves. So therefore, their electronegativity is defined as 0. And another piece of information that can help us remember this trend is knowing that fluorine is the most electronegative. So looking at the periodic table, fluorine is located in the top right quadrant of the periodic table. And because it's located in that general direction, that is the direction where electronegativity increases. Now let's take a look at ionization energy. Ionization energy is the same trend as electronegativity, in that it increases as you go to the top and towards the right of the periodic table. The only difference is that we now include the noble gases, instead of excluding them like we did in electronegativity. Ionization energy is defined as the energy required to remove an electron. The reason we include noble gases is that since they are already stable, they really don't want to give up an electron. Removing an electron generates measurable energy, and we can include them in the category for ionization energy. Since noble gases are already stable, they have the highest ionization energies because they really don't want to give up that electron. Another important thing that we need to know is that an element can have multiple ionization energies. For example, magnesium has 2 valence electrons. Removing the first and second electrons don't really require much energy, but removing the third requires a lot of energy, as we can see here. Finally, there is electron affinity. This trend is the same as electronegativity, and we also exclude the noble gases, much like electronegativity, since they already have an octet. Electron affinity increases towards the top right of the periodic table, like ionization energy and electron affinity, once again. Electron affinity is defined as the energy released when an electron is attached to a neutral atom. I like to think of it as how much an element wants an electron. Therefore, the halogens have the highest electron affinities. So in the case of fluorine and chlorine, they have 7 valence electrons. They really want that extra 1 electron to push them towards the noble gas status, which is the most stable in terms of electrons. The one thing to keep in mind is that chlorine has a greater affinity than fluorine, despite what the trend suggests. One piece of information that we just need to remember. So chlorine is going to be higher than fluorine in terms of electron affinity. And that's pretty much the major periodic trends. Leave a like, comment, and subscribe if this video was educational. If I made a mistake or if you have some questions, leave a comment down below. See you guys next time.